So in this video, I'm going to talk to you about ratios and proportions. So what is a ratio? A ratio is simply a comparison by division. It describes a relationship between two quantities or objects. For example, let's say we have an office. And in that office, we have 20 men and 10 women. We can say that the ratio of women is 20 to 1, but we can further reduce that by dividing by 2, which gives us 2 to 1. But with a ratio, we write it in this form, 2 to 1. There's 2 men for every 1 woman. So what this ratio means is if you're walking through the office, for every woman you encounter, you would have likely encountered 2 men. That means if you're walking through the office and you say hello to 8 male employees, you would have likely said hello to 4 female employees, because the ratio stays the same. If you said hello to 8 male employees, you would have likely said hello to 4 female employees. If we reduce the ratio, it will come down to 2 over 1. 2 male for 1 female. So that's basically what a ratio is. It describes a relationship between two numbers. The word ratio comes from the word rational, which means fractions. And because a ratio is just a fraction in a different form, we can treat them as a fraction. Let's say we have a ratio of 2 to 8. We can change the numbers of the ratio, but the relationship between the numbers stays the same. Let's say we had 4/16, and here we have 2 8s. That's our ratio. Here we have 1/4. Here we went this way, and here we doubled this way. Even though they're completely different numbers, when you reduce them to this. That means all of these ratios are the same. They are equal. This is a ratio of 1 to 4. This is a ratio of 1 to 4. And this is a ratio of 1 to 4. The relationship between the numbers stays the same, because if we divide this by 4, we get 1/4. If we divide this by 2, we get 1/4. So now that you understand what a ratio is, let's take a look at how we can use them to solve problems. And this brings us to proportions. A proportion is basically an equation of two ratios. Let's say we have an equation of 1/4 equals 2 8ths. This is a proportion. These two sides are equal. But generally in proportion problems, one of these numbers will be replaced with an unknown. Let's say, for example, we have 1/4 equals x/16. So this is the unknown, and we're trying to solve for that number. But we know the relationship between the numbers. Because we know the relationship of the numbers, we can solve for x. So how do we get 4 into 16? We multiply it by 4. So we multiply this side by 4, multiply the top by 4. 4 times 4 is 16. And 4 times 1 is 4, equals 16x. Because the denominators are the same, we know that the numerators are the same as well. So we know that x equals 4. X equals 4. So this is how we can use ratios to solve problems. Let's say this ratio of 1/4 represented, let's say this ratio of 4:1 represented the amount of red marbles to blue marbles in a bucket. And you wanted to know, if you reached into the bucket and grabbed 16 red marbles, how many blue marbles will you have had? And you can use proportions to solve that kind of problem. In this case, you would have had 4 blue marbles if the ratio is 4 red to 1 blue. Now let's work some problems. In this first problem, we won't be solving for any unknown. We just want to know which ratio is bigger. Let's say we have the ratio of 4 and 6, 4 to 6, and a ratio of 5 to 8. Which of these ratios is bigger? Is it 4 to 6 or 5 to 8? It's difficult to tell which one of them is larger when they're in this form, but we know that ratios are just rational numbers, so let's write them as fractions. Let's change 4 to 6 as 4 over 6, and 5 to 8 as 5 over 8. Now, even in the rational form, it is still difficult to tell which one of them is larger because the denominators are different. So the first thing we have to do is make the denominators the same. So to get a common denominator, let's multiply the 8 by 6. Multiply the 6 by 8. And whatever we do to the bottom, we have to do to the top. So once we multiply this fraction by 8, 4 times 8 is 16, and 6 times 8 is 24. When we multiply the 5 over 8 by 6, we get 15 over 24. Now that the denominators are the same, we can see that the numerator tells us which one of them is larger. Here we have 16 of the 24 pieces, and here we have 15 of the 24 pieces. So the fraction with the larger amount of pieces is obviously the larger fraction. So let's work another problem. Let's say we have a ratio of 3 to 7. A proportion of 3 to 7 is equal to a ratio of x to 35. The x here is the unknown. That's the number we're trying to solve for. The first thing we want to do is put the ratios or the proportion in fractional form. So let's do that. 3 to 7 becomes 3 over 7. And x to 35 becomes x over 35. What the equal sign is telling us here is that this side is equal to this side, or is proportional to this side. What that means is whenever you have proportions that are equal, you know that the left side is equal to the right side. What I mean by that is, let's say we have a proportion of 4 to 6 is equal to 8 to 12. You know that they are equal because when you cross multiply, the value on each side is the same. When we perform the cross multiplication, we find that both of the sides are equal to one another. So let's say we have 4 times 12 gives us 48, and 6 times 8 also gives us 48. Cross multiplication tells us that these ratios are equivalent. One side will always equal the other side. And you can kind of see that. If you look at this fraction and look at this fraction, you see that this fraction is just a multiple. This fraction is just a multiple of this fraction. See, 4 is multiplied by 2 and 6 is multiplied by 2. So they are equivalent. This holds true for this problem as well. Both of these fractions are equivalent. Even though we don't know what the number is, we know that they are proportional to one another. Because we know that these ratios are equivalent, we can simply multiply this fraction until we get the 7 to 35. For example, let's say we multiply this fraction by 3. Multiply by 3. We'll get 9/21. If we multiply this fraction by 4, we'll get 12/28. As you can see, this can be a very lengthy process to solve it in this way, and the number by which we need to multiply it may not end up being a whole number. So we need to find a mathematical way to solve this proportion. And the method we're going to use to solve this proportion is cross multiplication. We're going to cross multiply the numerator and the denominator on both sides. So 3 times 35 is equal to 7 times the unknown, 7 times x. 3 times 35 gives us 105. And 7 times x is just 7x. So now what we do is we need to isolate the unknown. So we cancel out this multiplication by dividing by 7, and we also have to do it to the other side. X multiplied by 7 then divided by 7 cancel out, and 105 divided by 7 gives us 15. So now we have 15 on the left side, and we just have the unknown on this side. So we know that 15 is equal to the unknown, which means that this number is 15. 3 to 7 is as 15 is to 35. Now, cross multiplication is not some new rule that we've invented to solve proportions. What we're doing when we cross multiply is that we're making the denominators the same. So in our example, we had 3/7 is equal to unknown over 35. Now we know that these two fractions are proportionals. These two ratios are proportional. 3 to 7 is proportional to x over 35. Now for us to see what the numerator is equal to in this version of the ratio, we must make the denominators the same. And the way we make the denominators the same is that we multiply this ratio by 7, top and bottom, and we multiply this side of the ratio proportion by 35. As you can see, the denominators are now the same, 35 times 7 and 35 times 7. As you can see, the denominators are now the same. On this side we have 35 times 7, and on this side we have 35 times 7. Because the denominators are the same, we know that the numerators are the same. So we can just forget about the denominators and focus on the numerators. The numerator here is 35 times 3, and the numerator here is x times 7. So what we are doing here is no different than what we did up here. We found a common denominator, and now we see what the numerators are equal to. Here we just cross multiplied because we know that when we cross multiply, the numerators will be equal to one another. We have 35 times 3 and 7 times x, which is what we have. And this is exactly what we have here, 35 times 3 and x times 7, which is a result of multiplying each side by the denominator of the other side. And we don't really care about the denominators because we know that they are going to be equal. Here in the longer process, we get the same results that we would get if we were to cross multiply 35 times 3 and x times 7. So let's do another problem. Let's say we have a ratio of 9 to 12, and it is equivalent to 33 to something. That's a letter that's unknown. The first thing we do is we put it in fractional form. 9 to 12 becomes 9 over 12, and 33 to the unknown becomes 33 over the unknown. So we just cross multiply, and it will give us the equivalent numerators. So on one side we'll have 9 multiplied by x is equal to 12 multiplied by 33. On this side we'll just have 9x is equal to, and 12 times 33 is 396. Now we isolate the unknown. We divide it by 9. 9 divided by, multiplied by, x multiplied by 9 and then divided by 9 is cancel out. And on this side, when we divide by 9, we get 44. So, and on this side we just have x. So x equals 44. So our proportion is 9 over 12 is equal to 33 over 44. Or in other words, as a ratio, we get 12 is equal to 33 over 44. And if you want to double check that they are equal, we can reduce both of these fractions. And we can reduce this one by dividing by 3. We divide by 3 and divide the bottom by 3. We get 9. 3 goes into 9 3 times, and 3 goes into 12 4 times. So on this side we have 3/4, and on this side we can divide by 11. We divide by 11. We know that 11 goes into 33 3 times, and 11 goes into 44 4 times. So again, on this side we also have 3/4. So we know that these are equal. Now we can also use proportions to solve percentage problems, because a percentage is basically a proportion. Because a percentage is basically a fraction, which means that it's a rational number or a ratio. Let's say we have 24%. 24% means 24 per 100, which means we can write it as a fraction, 24 over 100, which can also be written as 24 as a ratio, 24 to 100. Now there are 3 types of percentage problems that you can encounter that are all a variation of this form. You have percentage of some whole number is part of that number. This is a percentage. Both of these are numbers. Let's say you've translated a word problem and you find that what it's asking you is 25% of 32 is what? This is the first problem. 25% of 32 is what? First we convert it into a proportion. We know that 25% means 25 out of 100, so we write that 25 out of 100. And we have half of the proportion problem completed. Now for the second part, 25% of 32 is what? So 32 is the whole number. It goes into the denominator. And the unknown is in the numerator. We're looking for how many pieces of 32 we have. So now we just cross multiply. We multiply 25 times the denominator and 100 times the unknown. So 25 multiplied by 32 on one side, and 100 times unknown on the other side. 25 times 32 gives us 800, which is equal to 100x. Now we isolate the unknown by dividing by 100, which cancels out. When we divide the 800 by 100, 100 goes into 800 8 times. So the unknown variable is 8. So what this tells us is that if we were to draw it out, this ratio, if we were to draw it out and cut the whole into 100 pieces, just as the denominator says, and to shade 25 of those pieces, that would be equal to, if we were to cut this into 32 pieces, the same amount of the pie would be shaded. The value of these ratios is exactly the same. But in this case, if the whole is cut up into 32 pieces, only 8 of them will be shaded to give the same value. If we cut up the whole into 100 pieces, we'll have 25 of those pieces. So let's work another problem. In this problem, we have the percentage missing. That's what we're trying to solve for. But we have the total and parts of the total. So first, let's turn this problem into fractions and then solve it with proportions. So percentage converts to x over 100, because that's what percentage means, per 100. Then we have out of 85 is 13. So 13 goes on top in the numerator and 85 goes in the denominator. So now we just cross multiply. X times 85 is equal to 100 times 13. 85 times x is just 85x. 100 times 13 is 1300. Now we divide 85. X multiplied by 85 then divided by 85 cancel out. So leaving us with just the unknown. Now 1300 divided by 85, or 85 goes into 1300. If you run it on your calculator, it's 15.29 times. And that's percent. So 15% of 85 is 13. So let's work another problem. In this problem, we have the percentage and we have the number of pieces, but we're missing the total. We start off by converting this problem into fraction form. 30% converted into a fraction is 30 over 100, and that is equal to 42 is the number of pieces we have that goes in the numerator, and the unknown goes in the denominator. Again, we just cross multiply, and that will give us equal numerators. So 30 times x is 30 times x, and 100 times 42 is 100 times 42. This is just 30x equal to 4,200. Now we eliminate the multiplication by dividing, and we have to do the same to the other side, so these cancel out, and 4,200 divided by 30 gives us 140. So 30% of 140 is 42.